All right, ladies, in this video, we're going to go through the questions for 4J. Obviously not going to do every single question, but hopefully enough to work with you, and then you go off and do some on your own. So for the first few questions, we're just going to be doing some conversion. So I've kept my scribble from the previous video, and this great big green symbol is what we need to remember for our conversion. So if we're going from degrees to radians, we multiply by pi on 180. And if we're going from radians to degrees, we multiply by 180 on pi. Okay, so even though you might remember 90 degrees is the same as pi on 2 radians, let's just do the conversion properly. So we've got 90 degrees. So if we're converting degrees into radians, we're multiplying by pi on 180. So that's 90 pi on 180. And that 90 and 180 simplify. So you get pi on 2. All right, 225. So we're converting again to radians. So we're going to multiply by pi on 180. Oops. So we get 225 pi over 180. Now you should really try to do as much of this without using a calculator. So I know that is going to be, let me just think. Okay, so looking for the highest common factor. I'm just going to go with 5. Let me just think. All right, so the highest common factor is 45. So 45 goes into 225 5 times and into 180 4 times. So that's going to be 5 pi on 4. And I should really write the radian symbol. Okay, then for question B, we're going the other way. So we've got 3 pi on 4 radians, and we're converting it into degrees. So we're going to multiply it this time by 180 over pi. All right, so this is probably a little bit harder because you've got a fraction multiplying a fraction. So the easiest way to do this, let me just use a different color. Actually, I might just keep it in green. So 3 pi on 4 times 180 on pi. So your pi's are cancelling out. Okay, so that might make it a little bit easier for you. And you can then, instead of doing 3 times 180, you can switch your denominators. So it's going to be 3 times 180 over 4. So 180 over 4 is 45. So 3 times 45 is, what is that, 135 degrees. All right. Again, you can use your calculator, but I encourage you to try to do as much as you can without your calculator. All right, so then we've got 7 pi on 6, so we multiply that by 180 on pi. So I'm just going to rewrite that. Probably don't need to, but I like everything in the same color. So 180 over pi. So your pi's can cancel. The 6, you can change that to be 7 times 180 on 6. So I think it's a little bit easier if you're doing things in your head to, instead of multiplying the 7 and the 180 and then dividing by 6, just make things a little bit easier for you. So 180 divided by 6 is 30. So you've got 7 times 30, which is 210 degrees. And if you needed a little bit of help, you can do that on your calculator. All right. Question 2, again, I'm not going to do every single one. So I might just do, I don't know, do A. So if we're going from 60 degrees to radians, we're going to be multiplying by pi on 180. So that's 60 pi on 180. So 60 over 180 is, was that 1/3? So we've got pi on 3. Let's do a radians one. So let's do E. 3 pi radian on 4. So when we're doing that conversion, we're multiplying by 180 on pi. So if you want to, let's cancel those pi's out here. Oops. I just realized I wrote pi and not 4. I might just rewrite 4 here. And then we're left with 3/4 times 180, which is the same as 3 times 180 on 4. 180 on 4 is 45, so 3 times 45. Oh, we just did that one, didn't we? 3 pi on 4. 135. All right, let's do maybe G. Just do a few and then pause the video and have a go at doing the others on your own. I encourage you to do all of them. So we're converting into degrees, so 180 on pi. So your pi's can cancel each other out. So then we're left with 5 times 180 on 3. 180 on 3 is 60, so 5 times 60 gives you 300. And I should probably put my degree symbol on and my radian symbol here. All right, so girls, have a go at doing the rest. I'm going to move on to question 3. All right, find the exact value for each of the following. Now, there's 2 ways you can go about this. You can either draw your triangle or you can use your table, okay? But assume that you don't have the table with you, so you'd have to write that. Now you can actually see that we've got other values other than 30 and 45. All right, so we've got 150, 120, 135, 135, etc., etc. So you need to use your reference angle. All right, so I'll show you, maybe I'll just do cos 30. Just quickly. So that's 30. And that's 1, oh gosh, now I'm trying to remember the triangle. There's 2 on the hypotenuse and √3 on the bottom. Oh, I've gone too far, sorry. Where are you? 1, 2, √3. Okay, so cos theta equals adjacent over hypotenuse. So cos of 30, adjacent side is √3, and your hypotenuse is 2. So you could use this triangle or you could use your table of values to get that value, √3 on 2. Now, if we were to do something like E, which is cos of 150, this is where you need to use your knowledge of the unit circle. Okay, so if we draw the unit circle, now 150, we're going to be in the second quadrant. So we're here. So remember this angle here is 150, which makes this angle in here 30 degrees. So remember we did this back in 4i, so that's same as this angle here, which is 30. Now, you've got to also know whether you're positive or negative in this. So remember your A, S, T, C. So cos is actually negative in this quadrant. So we know that cos 30 is equal to √3 on 2. Cos 150 is the same, √3 on 2, But because 150 is negative in the second quadrant, your answer is negative root 3 on 2. All right, so let's do another one. So let's do F, because these questions are going to be quite tricky. Okay, so F, tan 120. So let's draw our unit circle, and all these angles I can see are in the second quadrant. So just draw our unit circle. So tan 120, so 120 is here. So remember, your angle always goes from the horizontal or your x-axis. So that angle in there is going to be 180 minus 120, which is 60. And that's the same as this angle in here. So we're going to be using this triangle, so 60 degrees here. Now, 60 degrees, if we go back to A, we can also use here. All right, so your triangle, if we're going to label the side alongside or adjacent to that angle is 1. Then the other side is root 3. So it's kind of like the opposite, and then 2 is your hypotenuse. All right, so let's just quickly do tan of 60. So tan 60, opposite over adjacent. So your opposite side is root 3 over your adjacent, which is 1, so it's just root 3. Now, in your second quadrant, so tan 120 is also equal to root 3, but because tan is negative in your second quadrant, you're going to have negative root 3. All right, now we don't have much more space here, so I'm wondering if I should do some more. Keep having a go at them, because it's pretty much, if you've understood 4i, you'll be fine with question 3. Might move on to question 4. And then I think that's the last question, is it? No. Okay. Let's have a look at question 4. So recall the exact sine, cosine, and tangent values for 30, 45, and 60. Okay, so they've been given to you in this table. State the reference angle for 225. Okay, so your reference angle, now I'm going to have to draw my unit circle here. $225, we're in the third quadrant, we're here. So we're basically looking for that angle. So that angle in there is 225 minus 180, which equals 45. So your reference angle for 225 is 45 degrees. It's the same. Now, going back to your unit circle, we know in quadrant 1, they're all positive. In quadrant 2, only sine is positive. In quadrant 3, tan is positive. And then quadrant 4, only cos is positive. So for question B, we're doing the exact value of sine 225. So it's the same as sine 45. So sine 45 is root 2 on 2. And in the third quadrant, sine is actually negative. So it's going to be negative root 2 on 2. Cos 45 is also root 2 on 2. And in the third quadrant, it is also negative, so it's going to be negative root 2 on 2. And then tan, so tan 45 is 1. And in the third quadrant, tan is actually positive, so it just stays as 1. All right, question C, state the reference angle for 330. So again, we're going to go to our unit circle. I might just use a different color this time. So 330, we are in the fourth quadrant. Remember, we always go from the horizontal. So that angle in there is going to be 360 minus 330, which is 30 degrees. So your reference angle for 330 is 30 degrees. Now, give the exact value of the following. So sine 330 is the same as 30 degrees, which is a half. But in the fourth quadrant, sine is negative, so it's going to be negative a half. Cos 330 is the same as cos 30, so root 3 on 2. But in the fourth quadrant, cos is actually positive, so it just stays as root 3 on 2. And then tan 30 is root 3 on 3. And in the fourth quadrant, tan is negative, so it's negative root 3 on 3. All right, the reference angle for 120. So let's try to do that in a different color. What color have we got? Let's use yellow. Okay, so 120, we are in the second quadrant. And remember, we always go from the horizontal, so that angle in there is going to be 180 minus 120, which is 60 degrees. So your reference angle is 60. All right, so sine 120 is the same as sine 60, which is root 3 on 2. And in the second quadrant, sine is positive, so it just stays as root 3 on 2. Cos 120 is the same as cos 160, which is a half, but in the second quadrant, it is negative, so it's negative a half. And tan 120 is the same as tan 60, which is root 3, but in the second quadrant, it is negative, so it's negative root 3. All right, let's have a look at question number 5. Give the exact value of the following. So for all of these, you need to find your reference angle. So I'm going to draw a larger unit circle just so it's not as messy. That probably will end up being quite messy. And we're just working with degrees here. So I'm going to put the degrees on. So 0, 90, 180, 270, and then we're back to 360. All right, so let's do sine 135. So sine, 135 is in your second quadrant. Remember, your angle always goes from the horizontal. So this angle in here is 180 minus 135. Can you tell I've got 45 in my head? I'm always a step ahead in my brain. That's why sometimes I'm quite quiet, because I'm thinking. So your reference angle is 45 degrees. Now we need to go back to your table. So we had one just here, so we might just go as far as here. So sine 45, root 2 on 2. And in the second quadrant, sine is positive, so it just stays as root 2 on 2. All right, let's do one that's a little bit harder. So let's do tan of 315. So 315 is in your fourth quadrant. Remember, we always go from the horizontal. So this angle here is 360 minus 315. So again, it's 45 is our reference angle. Let's go back to that previous table where we had 45 degrees. So tan of 45 is 1. And tan is negative in your fourth quadrant, so it's going to be negative 1. All right, I might do just this first column. So let's do cos of 225. Try to choose a different color. So 225 is in your third quadrant. And remember, we go from the horizontal, so that angle in there is going to be 225 minus 180, and it shouldn't always be 45. If I did some other questions, we would get 30 or 60. So let's go and find cos 45 on our table. So cos 45 root 2 on 2. And cos is actually negative in the third quadrant, so it's going to be negative root 2 on 2. All right, and let's do sine of 180. So 180 is actually here. All right. Now, the way you can remember this is, remember sine is y, the same as your y coordinate. At this point, the coordinate is -1, 0. So sine of 180 is actually 0. If you ever need to, you can go back to your tables that we filled in earlier. So in the building understanding, or even in your key ideas. Okay, so we filled in that table quite a few times to do these questions. Maybe I'll just do one more that isn't a 45. All right, running out of colours. Let's do a, let's do sine 240. So 240 will be here somewhere. So that angle is going to be 240 minus 180, which gives you 60 degrees. All right. Sorry, I just had, well, you probably don't know because I paused. So I just had to quickly go downstairs. So we're looking at sine 240. So sine 60, let's go up to this table, sine 60 root 3 on 2. And in the third quadrant, sine is actually negative, so it's negative root 3 on 2. So girls, complete the rest of those questions. I know there are a lot there, but it's very important that you get this practice. Okay, so draw as many unit circles as you need to. All right, question 6, write down the reference angle for these radian measures. So this time we're not working in degrees, we're working in radians. All right, so for these ones, you can, if you wanted to, convert them into degrees, but eventually you're going to be working in radians a lot more. So I'm going to do it just in radians. So let's draw our unit circle again. Okay, but instead of putting degrees on, we're going to be using radians. So 0, pi on 2, pi, 3 pi on 2, and then 2 pi. All right, and we've got to decide where each of these is on our unit circle first. So 2 pi on 3. Now, we're not quite before pi, so 2 pi on 3 is here. So this angle, just like we did before when we did 180 minus, we're just going to be doing pi minus 2 pi on 3. Now, if it helps, you can convert pi into a fraction with a denominator of 3. So that would be 3 pi on 3. So you're left with just pi on 3. So pi on 3 is your reference angle. And we don't have to actually do any more than that than find the reference angle. But if you look at question 7, which I don't think oh yeah, I have put it down. So question 7, we're actually then going to find those values. So let's actually do the first one because we're using pi on 3. So sine 2 pi on 3, we're going to use the reference angle of pi on 3. So I'm going to just write that down here. So sine, all right, sorry, my son just yelled out to me and distracted me. Okay, so sine 2 pi on 3 is the same as sine pi on 3, but in your, actually in your second quadrant, sine is positive, so that's fine. Now we've got to work out what sine pi on 3 is. So that's when you've got to go back to your exact value tables. So if we go back up, this table was in degrees, so I'm going to go a little bit further up. And so pi on 3 is the same as 60. So we were doing sine pi on 3, which is root 3 on 2. Now, instead of continually scrolling, I'm just going to use the values in my textbook, which is what you should be doing anyway. So root 3 on 2. And remember, sine 2 pi on 3 is in your second quadrant, so that's positive, so we don't need to change the sign to be negative or the answer to be negative. All right, let's go back up to the next question. I'm just going to quickly check the answer. I always like to make sure I'm on the right track. All right. 3 pi on 4. So let's do that in a different color. So 3 pi on 4, again, actually we'll do one that isn't in the second quadrant because that's in the second quadrant. All right, 7 pi on 6, so I'll do C. So 7 pi on 6 is just past pi. So to work out what this angle is, 7 pi on 6 minus pi. If you want to, you can convert that to be 6 pi on 6 just to make it easier to see. So 7 pi minus 6 pi is just 1 pi, so we're left with pi on 6. So your reference angle for that one is pi on 6. Now, let's see if there's one. Okay, so we've got, what was it? 7 pi on 6. Any of them 7 pi on 6? No. So I might do one. Let's do 5 pi on 6. 11 pi on 6? Okay, let's do 11 pi on 6. I'm trying to do one that's in both questions 6 and 7. So 11 pi on 6. Now 12 pi on 6 would be 2 pi. So we're kind of just before 2 pi with 11 pi on 6. So 2 pi minus 11 pi on 6. 11 pi on 6. If it helps, you can rewrite the 2 pi as 12 pi on 6. And that leaves you with 11 pi on 6. Sorry, 1 pi on 6. So pi on 6. All right, if I go down now to do question C. Sine 11 pi. Oh my gosh, I did it again. So used to writing pi, okay. 11 pi on 6 is the same as sine pi on 6. Now, if we go to our quadrants, 11 pi on 6 is in our fourth quadrant where sine is negative. So that is actually equal to negative. So we need to find sine pi on 6, which is the same as sine 30. So I'm not going to keep scrolling. So 1 on 2. And it has to be negative because we're in the fourth quadrant. So negative a half. All right, so go and have a go at doing the rest of those questions. They are a little bit harder, might be a little bit more time consuming to do, but very good to do them. Actually, I might do just one more from question 7. It was a long video. I feel like my computer might actually glitch on me. I was going to do G. Let's just do G because I wrote it down. All right, tan 5 pi on 6. So going to your unit circle, 5 pi on 6 is just before pi. So I might just write that here. It's a little bit easier. So pi minus 5 pi on 6. If you want, you can rewrite pi as 5 pi on 5 just to make it a little bit easy. Oh, sorry. 6 pi on 6. So much, because it's hard for you to actually know what's happening, but my neighbour is being really noisy and distracting me. Okay, so tan 5 pi on 6 is the same as tan pi on 6. Now, just check which quadrant you're in. 5 pi on 6 is in the second quadrant. So we're negative for tan. And let's just go up to the table. So pi on 6 is the same as 30 degrees. So root 3 on 3. You can go back to the other table if you need to, but I'm just conscious of the time. So G is going to be negative root 3 on 3. And guys, I'm going to leave it there because we've now gone to 30 minutes. All right, bye.